Okay, now let's solve this third exercise. And this deals about the tangent. Y equals tangent of 3x minus pi. The first thing we can see is the amplitude remains the same because we have just one in here, okay, just like one. This is going to be the amplitude and it stays the same. Okay, actually multiply by 1, right? It is not being changed. And the amplitude in the tangent, it is indeed something very difficult to work with, because we're not the tangent. Let me just bring up the chart of the tangent in here. This is the chart of the tangent, okay, and well, we can change the amplitudes. Let's write in here y equals 2 tan x. Yeah, the color is basically the same. Let's just change the color. It's not good. You see, it's stretched into this axis a little bit more. If we, let me just unzoom in here. Maybe it's better in this way. You see, we are stretching vertically, and if we just make y equals like 8 tan, stretching even further, you see it is being stretched up into the y direction. Okay, so but this is very difficult to draw, okay, especially for a student at high school. So usually we're not going to deal with this part in here, meaning that usually the amplitude, it is remain just one, it is the black one. Okay, one other thing I'm going to take the opportunity to illustrate in here, it is what you call the asymptote. Okay, and the asymptote, it is going to be this one. It is this green, okay, this green line in here, meaning if you just take forever and forever and forever, let's do something like this. Okay, the curve goes and goes up, 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 but you see it's not going to touch the green line, okay, the green vertical line. This is the asymptote, meaning this is the curve, the tangent, and this is the asymptote. The asymptote, it is just a line that the curve will never touch, but it is going to go sideways, but it's never going to reach, okay, this point in here. Just take this into consideration. Let me just bring up again our curve. Again, a little bit like this. Okay, usually that is how we see, okay, the tangent. Let's see, it goes like this, and then it goes to infinity, and then comes from negative infinity and continues. This is a tangent, but usually what students in high school have to know is at least this curve, only this one. Okay, but it goes repeating, okay, one after the other. It is the many cycles that we have, just like the cosine. This one, just like the cosine. This is one full cycle, right, over 2 pi. This is the same what happens to the tangents, but the problem is that the cosine where the cosine starts in here, one cycle. This is the end of the first cycle over 2 pi. Now we are starting over the same curve again. You see in here? The same one goes for the tangent. This is one period. Now this is for the second period, but they do not match, okay? But for cosines and sines, the end of one period matches exactly the beginning with the next period. That's why we can see just a continuous curve. But when you're dealing with the tangents, this is not the case. This is one period, this is another period, and so on. But let's just get back on tracks in here. So I have shown that is why amplitude usually is going to be 1 in here, because to stretch up the tangent, it's not something very easy to do it by hand, but it's possible, okay, to stretch up. Then what is going to be the 3? Well, the 3 it is going to have to do with our period. And remember, the rules are all the same. If this is multiplied by 3, if we multiply this x by 3, the period must be divided by 3. Meaning, we're doing this, right, with the period. We have the wave, and now we're doing this, okay? Just reducing, okay, just squeezing the wave like this. And now, the last part, red one I'm using, the phase. And the phase here needs some attention, okay? Because remember in the past video where I told you that, let's bring up in here, 1 second. Let's bring up the sine first. This is number 1. First exercise. Remember that the period, it goes from this portion up to this portion here. So the period, it would be this. 2 pi. This is the period. It means that every 2 pi, everything repeats again. You see? After 2 pi, we are going down again. Going down, going down. So every 2 pi, everything repeats again. And that is what happens in here. With the cosine, the same happens. I'm just going... yeah. I didn't want to go inside here, but I'll have to... okay. I think it's possible to illustrate what I want. Okay, this is 2 pi. Again, from peak to peak. Okay, so, and what happens after this peak? The curve is going down once more. Everything is starting to repeat again. So, for every 2 pi, we have a repetition of the curve, the function. But what happens when you are dealing about the tangent? The tangent is a little bit different. For tangent, the period, it is not 2 pi. For tangents, the period, it is just pi. And let me show you why is that. If we could draw this is a tangent of x, okay, this is our curve, and remember that asymptote is just like this one. Let's make it green. Why not? It is a line like this, and we have another one in here too. This is asymptote. Okay. Oops, starts with A. Asymptote. Okay. And what happens this line here? It means that we are going up, aren't we? But we will never touch the green line. But each time we go higher, we get closer and closer to the green line. But we are never going to touch it. And this part here, it is 90 degrees. But, okay, we don't write this in degrees. We usually write this in radians. It is just pi over 2. Okay. Later I'm going to explain why this happens, but so far we have to understand that if this is pi over 2, then this is going to be negative pi over 2, meaning that the period now is going to be pi. Okay, and remember, in the case of the cosine and the sine, whatever we have a shift in the phase, that it is the same as the period, nothing happens. We're just going exactly over the other one, just like this. We are shifting, let's say in degrees. Okay, it's easier to speak like this. Okay, imagine we have this curve, and this other one, it is the one we are trying to shift. So maybe this is 10 degrees. Okay, here it would be 0. Okay, perfect alignment. Okay, can't align it perfect, but maybe this would be 10 degrees, 20, 30, 40, 50, okay, 60, 70, 80, 90, and when we get a shift of 900 degrees, it would be exactly this. Okay, we just go one full turn. Okay, so whenever we have a shift phase for tangent, pi, 2 pi, 3 pi, okay, anything, any multiple, let's write it like this, any multiple of pi, okay, the shift phase will have no effect, meaning when we just switch a phase shift of pi, we're going to get exactly at the same location. This means that the phase shift in this case, yes, it should be to the right, positive pi, right? Negative here, the opposite, it is positive. So we're just going, if we have our initial drawing here, we're going to take this one and move exactly pi to the right. But when we move exactly pi to the right, we just land exactly on the other curve in here. Like, now I'm going to write twice, okay? It's going to be easier to understand. So this would be the first one. Let's just draw the asymptote because we need it. Okay, it's impossible to draw the other one if you don't draw the asymptote. Remember, the next one, it is going to, oh, just one thing, I need to put both ones. Okay, now it says, okay, 6 centimeters, so it's going to be this. The next one is going to be exactly here. Okay, let me just measure 6 with 6. Okay, this is the next asymptote, right? This is the middle. Okay, So that's where it's going to be. Then we just go like this. Okay, and the same goes. We also have another one. And we go, okay? This is for the first cycle, second cycle, third cycle, and so on. In here, we have 2 pi. In here, another 2 pi, and so on. Remember this one? This would be pi over 2. What does that mean? What is going to be the next one? Pi over 2 plus 2 pi. Oh, I'm sorry, just notice in here, of course, the period it is pi, right? I'm just saying, okay, that the period it is pi. I'm sorry, okay? It is just pi. Every time it's pi. Pi, pi. Because if it is pi over 2, this is going to be, let's continue a little bit. This is going to be minus pi over 2. So I have a pi, okay? Every pi, it is going to repeat the curve. If this is pi over 2, then this is going to be 3 pi over 2, okay? And so on, okay? In a way that the period, it is also going to be pi. Okay, so now it's very clear to see. We start in here. If we just shift pi, this is going to land in here. Okay, if this is 0, this is going to be pi. Okay, now if we shift this curve pi to the right, we are going to land exactly in here, so nothing is going to change. That is why when we have a shift of pi, it is the same, okay, as saying that we have a shift of 0. It is the same, okay? For charting, for drawing this chart, it is going to be the same. So this becomes very easy, and this is the answer. Let's just draw our answer in here. Well, the amplitude, nothing changed perfectly. Now what happens? Remember that okay, again, the phase shifts, we don't have any shifts. I mean, we do have, but it is not a shift that it is going to disturb those points in here, because they are going to be exactly at the same pace. So we can consider a shift of 0, okay, because every multiple of pi makes no effect for the shift phase. No shift phase. Amplitude is 1, and we are just shrinking 1/3. Okay, remember that line that I like to draw? This is 0. This is pi over 2. Remember, I always like to put those points. What is going on now? We have to divide by 3. Just put a 3 down here. Okay, this is 3, okay, pi over 6, okay? This is going to become pi over 6 because it used to be pi over 2. And again, what is going on is that we are going to have a much thinner curve. Instead of stopping at pi over 2, we are going to stop much before that. Now we are going to stop at 1/3, right? Because we are reducing the period by 3, okay? 3 times. We are dividing by 3. Instead of pi over 2, it is going to be 1/3 of that. And this is going to be pi over 6. And again, this is going to be minus pi over 6. And If we just add both sides, we just get a period of pi over 6 with pi over 6. It is just a period of pi over 3. Remember, this period has period pi, and everything on the x direction, it is going to be reduced by 1/3, right? If initially we had a period of pi, it's perfect understandable that now our period, it is also going to be reduced by 1/3. Everything on this x, okay, is going to be reduced by 1/3. That's what means this string here. Period pi over 3. Okay? And this is short from our answer. And again, this is just sideways thinking. Okay? The answer, the exercise is just this.